Okay, so welcome to the session 3 of Information System subject of the BIT degree semester 1. In this particular session, we are going to discuss about role of information systems in business. In the very first session, we discussed about various aspects related to information systems. In the session 2, we discussed about the business environment and concepts related to business organizations. So this is the session we are going to discuss about how information systems can be used to drive business into success, right? So this is a very important topic. So let's briefly look at the objectives for this particular session. First, we will be looking at how information systems can be used to support different levels of the business organization. Then how to use information system to get competitive advantage, basically how to support those strategies and tactics. Then we will move into discuss how information systems can be used to maximize the profit of the organization. So next we will be discussing about the component of IT infrastructure and also levels of IT infrastructure, or basically the layers of IT infrastructure, the hierarchical layers of IT infrastructure. Then we will discuss about types of IS resources and products, which include hardware solutions, software solutions, different data resources, and also we will be discussing about the human resource aspects like different professional roles, IT professional roles that will help not only building the information IT infrastructure but maintaining and administration and also use of the IT infrastructure. As a very last topic, what we will be discussing is the aspects related to globalization. So we will be discussing the opportunities, challenges of globalization and how to come up with strategies to exploit or use globalization for business organizations and basically build global businesses using with the support of global level IT infrastructure. Okay, right. So I hope you got the big picture, right? So we are going to discuss each and every aspects in this particular session, right? So let's move on to the topics, right? So we can use information systems for different levels of the business organization. So that is why information technology is a very critical feature for business organizations. That is why we have separate IT managers now, just like HR manager, finance manager. Now IT manager is also playing a very crucial role. Why? So IT manager has to work with other managers, senior level managers, to align IT infrastructure into different levels of the business organization. So at the very top level, we can use IT infrastructure to help implementing business strategies to get competitive advantage. Then we can use information systems to for support decision making of the managers. At the low level, we can use information system infrastructure to day-to-day process and operations. So you can see we can use infrastructure, IT infrastructure from very top level things like strategic management to operational tasks. Right. So if you properly implement IT infrastructure in a business organization in a sensible, thoughtful manner, you are going to have got a lot of positive results. So we have mentioned few of those things. So we are going to have some, or the business organization is going to do some proper decision making. Organization is going to get better competitive advantage, better collaboration with partners, business partners, better communication with inside the organization, increase productivity, right? Increase sales, increase customer satisfaction, and many more, right? So that is why we want to have proper information systems in the business organization, right? So let's see how we can map the use of information systems to the maximization of profits, right? So we know that basically the basic formula of profit, it's revenue minus cost. So if you want to maximize profit, basically what we have to do is increase revenue and if possible reduce cost. So both will contribute to increase of profit. So how to increase revenue? So there are so many ways you can increase revenues, but the most effective approach of increasing revenue is increase the sales, right? So if you keep increasing the sales, so if you are selling more, definitely the revenue is going to be more and more. So in order to do that, you can do so many things, like you can do some marketing. For that you can use information systems, right? Specialized marketing related information systems. You can go for online sales, right? Definitely you are going to have bigger new market segment open the moment you go for online sales. Then you can use information systems to support better customer services. Then the customers are going to like our organization. They are going to be more loyal with our organization, thereby increasing the sales. So increasing the sales will increase the revenue. That means increasing the profit. And as we saw, we can use information systems to increase sales uh, in a different ways. Again, we can use or we can increase the profit by reducing the cost also, right? So for that also we can use information technology. So basically, how to reduce cost? The best or the main approach is increase the productivity of the organization. When we increase the productivity, the cost is going to be lower and lower. So in order to increase the productivity, we can use a lot of business information systems, right? So we can take better decisions. We can use a lot of transaction processing systems. The moment we introduce a transaction processing system, the productivity of the organization is increased, and also we can reduce number of employees also, right? So thereby reducing the cost, so which contribute to the increasing of profit. Right, now let's see how we can use information systems for strategic approaches, like to gain competitive advantage, right? So in the second session we discussed about different business strategies business organizations can adapt depending on their uh, situations. Like once we do the analysis, we can decide which strategy we are going for, right? So there are popular strategies we discussed last time: quality leadership, innovation, cost leadership, customer oriented business, etc., right? And there are some tactics also, right? Improved agility, partnership, etc. So not all, everything is mentioned here. We have just taken few of those strategies and tactics here. The full list we discussed in the last session, right? So whatever strategy you pick, depending on your business environment and your weaknesses and strengths and etc., whatever strategy you pick, there is a way to, or there are some ways you can use information systems to achieve that or help achieving that objective, right? So I'm not going through each and every strategy, how information systems can be used. Those things are mentioned in the note. I will take in some one or two strategies. Assume that the organization has decided to go for quality leadership, right? So that means they try to come up with the best quality product from the among the competitors. Definitely we can use information systems, right, to increase the productivity and also continuous improvement. For example, we can have the, if it is a manufacturing based organizations, we can have a lot of engineering automations, and also a lot of controls we can introduce using information systems, so that the quality is keep on increasing. That means less and less defective items will be there, or the products will be uh, at all time within the quality criteria, right? So let's take another example, something like cost leadership. If the organization decide to go for cost leadership, definitely information systems are going to be help. Why? When we go for cost leadership, one thing we want to make sure that we reduce our expenses or cost, then only we can sell at lower price. So definitely we can use a lot of information systems. The moment you introduce information systems, like simple systems like say transaction processing systems, the things are going to be more efficient. We can reduce the number of staff, so thereby we can transfer that advantage to the customers by selling the product at lower price. So likewise, to name any strategy, there are ways you can use information systems. Actually, it's a very good task that you think about different strategies and how we can use information system. So that is very good exercise for you, right? So I will take just one more strategy. If the organization decide to go for innovation, definitely the heart of the implementation of innovation strategies, use of information systems, right? So for example, if you take some innovative business organizations like Uber, they are 100% sort of 100% based on information infrastructure like geographic information systems, right? So likewise, whatever the strategy or whatever the tactic, there will always the room for use of information systems, right? Now we are going to discuss a little bit about the structure or the infrastructure of, or the IT infrastructure of business organizations. Basically, the IT infrastructure we can subdivide into two areas: the technical IT infrastructure and the human IT infrastructure. So the technical IT infrastructure means the information systems and the related things. The human IT infrastructure means the supporting staff. Okay. Right, so let's look at what is mean by technical IT infrastructure. Basically, the technical IT infrastructure involves the hardware, the software, including databases, etc., and the network devices. So all those components are called technical IT infrastructure. Then we have the human IT infrastructure. So that is basically the professionals, IT professionals that we have to use to operate, maintain, administer, and also in some cases develop information systems if the organization has decided to have their in-house software development task as well, right? So that is human IT infrastructure. So you just have to understand that you can subdivide the IT infrastructure into the technical IT infrastructure and human IT infrastructure. Both are very critical, right? So the next what we are going to discuss is how to decide or what is mean by effective IT infrastructure for business organization, right? So obviously if a IT infrastructure is good one for a business organization, that is going to be effective. So effective means basically it does the work, it does the right things, right? So otherwise we can't say that the IT infrastructure is good one. Then a good IT infrastructure is always going to be flexible. Remember last time we discussed about the importance of agility in very dynamic business environment. The business must be very agile, then only they can very fast moving, right? So if the IT infrastructure is also agile or flexible, so we will be discussing those things later also. If the infrastructure is very flexible, easy to change, easy to modify, easy to improve, then we are in a very good shape to for our business advancement of our business. So that is why we try to make our IT infrastructure also agile. Then a good IT infrastructure is going to be robust. So when we say robust, basically the IT infrastructure must be efficient, it must be reliable, it must be secure, right? So if we have those features, we can say that yes, we have a robust IT infrastructure, we can rely on that, right? So those are some features of good IT infrastructure, how to find evaluate whether IT infrastructure for business organization is really good or average or not that good. Okay, so next what we are going to discuss is the levels or layers of IT infrastructure. So we can look at the IT infrastructure of a business organization as set of layers or hierarchical structure, right? So let's start with the bottom. So we can build our own IT infrastructures for the business on top of public infrastructure available. For example, if you take the mobile providers, they have their mobile platforms. The telecom providers, the telecom platforms, right? So and the public internet is also there, right? So we can use applications, especially if it is a web application or something, we can use those infrastructures. So public infrastructure is, it is not with us, but still we can use it, right? We can build our applications on top of the public infrastructure. So that is the lowest level in the infrastructure because we can also use it. Then on top of public infrastructure, we can build enterprise-wide infrastructure. So enterprise-wide means basically it spans across the enterprise. Right? For example, if you have a wide area network or set of local area networks, so those are enterprise-wide infrastructures, right? So if it is a fairly big organization, we may have data center having all the web servers, database servers, email servers, etc. that can be accessed by from any other business units, or basically from all the within entire business organization. So those infrastructures are called enterprise-wide infrastructures like networks, data centers, etc. On top of enterprise-wide infrastructure, we can have another layer. So you can see it's subdivided. Here we have the corporate infrastructure. For individual business units, we have the business unit infrastructure, right? So the corporate infrastructure is basically for the high level things, like for example, if the corporate need to interact with the government, say to pay their tax, or if we want to communicate with uh, harbor or customs to clear our goods and imports, we can use the corporate infrastructure, right? And also for strategic managers, they will be also using the corporate infrastructure for various tasks. So parallelly, each business units like HR department, finance department, or in some cases it can be branches, parallelly, just like corporate infrastructure, they have their own business unit infrastructure, right? For example, if the business unit is finance department, so the finance department may have their own servers and maybe having their own applications like finance MIS, right? So that is business unit infrastructure. So those infrastructures are going to be used only by that particular business unit. So it can be built on top of the enterprise-wide infrastructure, right? So then each and every business unit will be having their own local IT tasks, right, to utilize those infrastructures. Okay, like for example, finance manager will be using the finance MIS, and also the finance department will be using the accounting systems. The HR department will be using leave management systems, employee appraisal systems, etc. on their local uh, business unit infrastructure. And also they will be using, for example, if the organization is having enterprise resource planning system, they will be also using that also, right? So that is how we look at the levels of IT infrastructure of a business organization. It starts from the public infrastructure, next the enterprise-wide infrastructure, then either corporate infrastructure or business unit infrastructure. Then on top of that, there are some local IT activities. Okay, right. So next we are going to look at the different information system resources and products. So that is very self-explanatory actually. So let's look at from easier things. So we are going to have some hardware resources like machines and other media, etc. We are going to have some software resources like system software and application software. Some data resources, we are going to have some databases, data warehouses, computer files, etc. Then network resources like communication media, network utilities, some network controlling software, etc. Then we will be having people resources. That means the HR or the human aspects of information system. Like we will be having some specialists like software developers, business analysts, IT managers, etc. And of course, we will be having as part of people resources, we can consider even end users as well, because they are going to use the information systems, right? So that is the product wise. Then information wise, so that is why we call it information system resources and products. We have information products also as part of the information systems. Basically, information products are uh, result of using the information system rather than part of the information system. For example, the various managers will be generating different management reports, right? HR manager will be need generating some HR management related reports. The finance manager will be generating some finance related reports to their this decision making. So those are part of information products. So basically information products are the results of using information systems. Another type of information product is various business documents. For example, if you are using some transaction processing systems, it will be generating orders, invoices, payment vouchers, etc. So that is another information product, just like management reports. So altogether we can call them those as information resources and products, right? So these are basically the products, these are basically the resources. Okay, right. So now we are going to discuss each and every component little bit in detail. For example, we will be discussing about the hardware resources first, then software resources, data resources, right? The network resources, and the people aspects, right? People aspects. We are not going to go into details about these things because these are very straightforward. Okay, so let's move on to the hardware resources of business organization. So you can see that the hardware resources include machines, media, etc. So we are not going to discuss these primitive things because as information system students, you know these things already. What we are going to discuss right now is some high level concepts and some strategic or tactical and new concepts when it comes to hardware resources. We are not going to discuss about computers, disk drives and those things. Some high level, strategic level concepts when it comes to hardware resources. Okay. So the first concept that we are going to discuss is the concept called on-demand computing. Right. So on-demand computing means we use hardware resources then and there when we need it. So rather than buying hardware resources, like rather than buying a server, we can use on-demand computing, or we can basically go for cloud computing, and from a cloud provider we can hire a server for the maybe for 1 year or just enough for our task. So then we just have to pay rent rather than buying the product. Then once we are done with that, we can just discontinue the rent. So that concept is called on-demand computing. So it is getting more and more popular right now because otherwise we have to spend a lot of upfront investments, and also we have to manage our hardware resources. Then when we are not using, or when we are done with the hardware, we have to at least resell, or so it's a burden for the organization. But when you go for on-demand computing, we can just get it as a service, pay for the service, then we are done. And also they will be maintaining, administrating, and all those things will be done by the service provider. Okay, so that is concept of on-demand computing. This is closely related to the cloud computing. Anyway, we will be revisiting cloud computing also later. Okay, right. So this is another concept. So we are just familiarizing with some modern concepts that we can use in business organizations as part of hardware resources, right? So another concept is called grid computing, right? So in order to understand what is meant by grid computing, so we are going to take an analogy or examples from different fields. So we are going to take an example from electricity field. So you may have heard the word electricity grid, right? So when we say electricity grid or grid, so you can see there are various power plants, right? So if you take from Sri Lankan context, Victoria, right, Ramdenigala, Kalanithissa, and so many, Morichole, and all those power plants are contributing to the national electricity grid. So in the electricity grid is going to manage all those complexities of managing this supply of the power from different power plants, right? Then it will be distributed to the end users like houses, industrial factories, etc. So if you are a house or factory, we don't mind from where the power is coming, right? we don't specifically ask power from Norwich or power from Randenikala. We just need power, right? So that complexity of handling or integration of these power, the supply is handled by the electric grid. So that is why we have the electrical engineers in the CEB, right? So to manage these complexities. So that concept is can be used for information system technology as well. So when we use the same concept in information system, we call it grid computing. So basically what is mean by grid computing is, now we have a lot of public infrastructure and also the internet and those things. Therefore, we can have our servers and other resources spread across different locations, right? Just like having a lot of power plants here and there. So when we need some processing, we can just request for that processing, and we don't mind which server is going to do that. We don't mind whether that processing is done by this server or this resource or this resource or some other resource. As long as it is done by any of the resources, we are okay. So in order to do that, there we need some middle level softwares to do the coordination. If we can do like that, we call it grid computing. So now we have that infrastructure and there are some softwares to manage those complications, uh, and so that concept is called grid computing. So the next question is, okay, you may ask, why do you need grid computing, right? So the simple answer is, now business organizations need more and more processing powers because they are having hundreds and thousands of needs. Therefore, the local machines are not going to work in most of the cases, and also the machines or the servers are going to be overloaded most of the time. But if we implement it as a grid computing, the load will be shared, right? If when one server is busy, you will be redirected to another server to do the processing, right? As long as you get the results, you don't mind from which server you are getting the response, right? So that is the beauty of grid computing. So we can just subdivide grid computing into three categories also: computational grid, data grid, and collaborative grid. So basically the computational grid is what it does is, it manage distributing the computation or the processing into various servers and get the work done from one of the servers. So one or collaboration of different servers. So if the distribution is the processing, we call it computational grid. Then we can have data grids. So data grid means if it is a data related things, you can use different servers or resources to cater your requirements. As long as you get the data, you don't mind from where you get the data. So it's for you, it's you are getting the data from the grid, right? So as long as you are getting the data, you don't mind. If we can implement that kind of approach, we call it a data grid. Third one is called collaborative grid. In that case, the grid software is going to do some collaborative tasks. So if you need to get some collaborative task, that means you have to get some processing from the server A, then you have to call server B with the results of server A. The server B is going to do some other processing and give the results back. So that kind of, if the task is complex and you need some collaboration from different uh, resources, that kind of grid is called collaborative grid. Okay, so we can have the computational grid just managing the processing, data grid just managing from where you get the data or where you are saving the data, collaborative grid to get some complex tasks done, which has various tasks. Okay, so that is grid computing. Right. So the third type of hardware related concepts that we are going to discuss is called edge computing. Right. So edge computing can be understood if you first understand a little bit of cloud computing also. Right. So this is how the cloud computing works. So when it comes to cloud computing, so we have our servers in the internet. right, by a cloud service provider. So when we need something to be done or get some processing or get some data, we will request in the cloud, and the cloud will do some processing or whatever, retrieve the data, etc., and give you the results back. So that is how the cloud computing works. So basically this is a public infrastructure internet. So the difference between cloud computing and edge computing is, in edge computing, while we are having these cloud servers, we will be having some edge servers also. So you know what is meant by edge? අපි කියන්නේ ගැට්ට නැත්නම් end එක කියලා. So we have a server very close to us, right? So at the edge of our access we have another server, right? So then what happens is, when we request something, yes, the request might go to the, it will go to the cloud server in the internet. At the same time, part of the processing may be done by edge server, or sometimes some data will be cached in the edge server. In that case, rather than you are getting all the information or the data from the cloud server, you are getting part of the data from the cloud server and some part of this data from the edge server, or maybe some frequently used data like cache data you are getting from the edge server. So what is going to be the results? The end user is going to get the results much more faster, right? So the end user experience is going to be improved. So if you are implement that kind of things, we call it edge computing, right? So edge computings are usually used by the big companies, big business organizations, especially when it comes to organizations like Facebook, Google, YouTube. They heavily use edge computing, right? For example, if you have a video which is very popular these days in Sri Lanka, so they can have that video cached in an edge server close to Sri Lanka, or at least, or maybe the servers, they have their own edge servers in our ISP providers as well, like SLT, Dialog, etc. So they can cache some of the frequently used things in the edge servers. Then those things will be returned to the end users from the edge server. If it is not there in the edge server only, it will be taken from the cloud computers, right? So that is, the concept is called edge computing, right? Edge computing. So now we have discussed about the grid computing, on-demand computing, and edge computing. So the next concept related to hardware and little bit related to software also is called autonomic computing. Right? So when we say autonomic, autonomic means autonomy means independence. So you can do something by yourself. So basically, autonomic computing means the computer itself can do certain tasks that used to be done by the operators or system administrators, right? So we see what are those tasks that the computer itself can do right now. If the computer can itself can do those things, we call that autonomic computing, right? Right. So these are some tasks that autonomic computing system can do by itself. Self-configuring, self-adaptive, self-protective, self-healing, right? So those are some concepts related to autonomic computing. So let's take one by one. Self-configuring means the information system itself can do some configurations without the help of system administrator. Right? If that capability is there, we call it self-configuring feature is there. That means it's a autonomic computing. Right? For example, so if the information systems or the information IT infrastructure itself can do some software upgrades without the involvement of the system administrator, so that is self-configuration, right? So if when the passwords are going to be expired, if the information system itself can generate some passwords and keep the sessions, so that is self-configuration. So typically those things are used to be done by administrators, but now the autonomic computers or autonomic computing means those things can be done by the computer itself or the information system itself. So which make our burden for the information system professionals, right? So they have less tasks now. Another one is self-adaptive. So self-adaptive means the information system itself can adapt to various demands and changes in the environment. Like for example, if there are high demand for processing power or lot of hits or lot of access are coming, so the information systems itself can increase the memory, or it can itself can increase the number of servers without the information system administrators involved in that. If that is the case, that is also autonomic computing, self-adaptive. Then self-protective means if there are some threats or possible attacks, the information system itself can trigger security measures without the system administrator or security specialist triggering those things. Another thing is self-healing. That means if there are some many issues occur, like uh, some software failures or even some hardware failures, the system itself can quickly restore using the latest backups and etc. And after some times, the system is again going to be live without the involvement of the system administrators. So if those features are there, basically we are talking about autonomic computing. Right. So the next one is not very technical thing, but important aspects, that is green computing. Green computing means we are using our information systems and infrastructures in an environmental friendly way. If we are using the information system in environmental friendly way, we say we are using green computing, right? So what kind of things that we can do? For example, we can use eco-friendly energy. For example, if we have a data center somewhere, we can set up some solar power or wind power to power the servers. So in that case, our carbon footprint is very low. So that is green computing. So likewise, we can do some other things also. For example, we can implement our information systems to use less energy, right? So we can have our best practices implemented in the business organization so that we are not wasting any resources. And also when we are discarding or throwing away our hardware resources, we can always use recycling and we can throw them away in a very professional way, in a proper way, so that we are not corrupting the environment, right? So if we are practicing those things, basically we are doing green computing, right? So that is just concept, right? So let's move on to another concept when it comes to hardware, that is use of virtual servers or virtual machine, right? So that is a very popular these days. So rather than having so many hardware servers, so many machines, we can have one or two very powerful server or set of servers and create so many logical servers out of that. So then we can assign those logical servers for different tasks, like maybe one of the logical server for our web server, another logical server for a database server, etc. But it's just one hardware, right? So if we are using those concepts, basically we are using the concept of virtual servers or virtual machines. Right. So then there are some more concepts like use of server farms, data centers, etc. I think those are very self-explanatory. You know what is meant by data center. If you have one particular central location where we have all the servers, etc., we call it the data center. And especially if it is a very big organization like Google, Facebook, they have server farms. So server farms means in that data center you have hundreds and thousands of servers uh, ready to serve the request. So if we have that kind of things, we call it a server farm. Okay, right. So what we have discussed so far is hardware aspects of information system infrastructure. So now what we are going to do is move into the software components of information system infrastructure, right? So this is very self-explanatory. The first subtopic, that is type of software. We have already discussed those things in computer system subject. That is, we can subdivide software into system software and application software. Right. So the system software will include operating systems, system utilities. Application software we can subdivide into general purpose software and application specific programs. So the general purpose software includes stuff like word processors, graphic uh, softwares, etc. Application specific programs means specific to a particular task like order processing systems, reservation systems, payroll systems, etc. Right? Then again the software. So now we are in software aspects. We can subdivide software according to the commercial aspects or license aspects, that is proprietary versus FOSS software. So the proprietary software usually we have to pay the, for the cost, or there is a commercial value to acquire the software, and also we will not get in the source code, right? So that those are proprietary software like Windows operating system, right? Adobe Photoshop, right? So those are proprietary software. FOSS software means free and open uh, software. Basically they are free of charge and source code is available. So those software is called FOSS software. For example, Linux operating system, right? The library office package, right? So those are FOSS software. So there is now tendency to go more and more into FOSS software, right? Right. So the next classification of software is, we can subdivide software into personal application software, workgroup application software, and enterprise application software. So that is very easy to understand. Personal application software means software that is used by individuals, right? Maybe for personal things or maybe for office environment, right? So personal doesn't mean just for personal use. No, that means basically personal means used by individuals, right? For example, office packages, word processing software, spreadsheet management systems, even personal databases like Access, and also graphic packages. Those are personal application software because it will be used by one person at a time, individually. Then we have work group application software. So the work group application software is usually used by set of people. We call them work group, right? So mostly work group software is used for communication and collaboration. For example, uh, Skype, Zoom, right? So Lotus Notes. So those are some popular work groups application software. Basically, those are used to improve the communication and collaborations within the business organization, right? Then the third type of software is, or the third type of application software is called enterprise application software, right? So basically we have a small issue when it comes to software or the information systems used in business organizations. That issue is, sometimes we call it information silo. That means information systems are built as individual isolated entities. That means I have information system A, information system B, information system C, likewise isolated information systems. But there are some issues with that, right? So there will be some lot of duplications. We have to do some lot of rework. Same data is in different systems. There can be some discrepancies like anomalies, right? So idea is, rather than building different individual information systems, try to build one information system integrated with each and every component, right? So then we can, so that kind of a big information system that cater for entire enterprise is called enterprise application software, right? Right? So enterprise application software, sometimes we call them enterprise resource planning or ERP software also. Basically ERP software will have so many features, right? You name it, it will be there, right? So for example, now let's see what are the typical components of an application software, enterprise level application software or ERP. Remember last time we discussed in the last session, every business organization have to have a value chain, or we can call it supply chain. The task related to the value chain or supply chain is called primary business activities, right? Then we have secondary or auxiliary business activities, and those are some supporting tasks like finance, accounting, HR management, marketing, etc. right? So the ERP software or the enterprise application software is going to support both these type of tasks. First, it is going to support the primary business activities, then also it will be supporting some secondary activities also. Now let's look at how the support for the primary business activities or the value chain. Definitely you are going to have some order processing functionalities. We call it inbound logistic. There will be inventory controlling and also custom order processing. Sometimes we call it outbound logistic. So together we can call the supply chain management. So enterprise resource management systems are going to support these functionalities of business organization. Okay. Then again some other functionalities related to the value chain like product to engineering support, customer relationship management, that is more into the sales and have good relationship with the customer for marketing and other purposes. So those are also going to be supported by enterprise level software. Then enterprise level software is going to support some supporting tasks as well, like accounting, HR management, marketing, etc. Right? So there can be some enterprise software which support almost all the features, right? Or maybe you otherwise you have to use separate transaction processing systems, which is not very good idea because there will be some overhead when it comes to the flow of the materials and data. Okay, so you can just go through what are the individual components of enterprise resource planning software. Right, so these are some popular ERP software. So there are a lot of commercial ERP software. So this is a very big industry, and also usually these ERP softwares are fairly costly also. So softwares like SAP, Oracle ERP, Microsoft Dynamics. So those are some popular ERP software. Right. Now we have discussed about different types of software like proprietary versus free and open source, application versus system software, etc. Now we are going to discuss different type of software architectures. Right. First we are going to discuss some basic architectures. Later on we are going to discuss some enterprise level architectures. Right. So let's look at some basic primitive architectures, right, or general architectures. So one of the general architecture, one of the very simple architecture is standalone application architecture. So when it comes to standalone applications, individual computers will have their own infrastructure, everything like the application, database, and all those things will be there. So usually standalone application, if the application is using standalone application architecture, it is not relying on the networks to do their tasks, right? But the only thing is those things are very limited in usages because most of the time we need to synchronize data, right? Synchronize with some business logic, etc. That is not possible when it comes to standalone application. But for individual productivity activities like word processing, spreadsheet management, etc., or maybe graphic processing, we can use standalone application architecture, right? So the next architecture, the next general architecture is called client-server architecture. So when it comes to client-server architecture, there are machines with two roles. Some of the machines are called client machines. Then we can have the server machines. So basically the client can only consume or request resources. Servers can only serve the request. Right? So that is very popular when it comes to web applications, email applications, etc. So web application is hosted in web server, and also there will be some database server also. So those can serve the request. Then clients will be using their individual uh, personal computers or laptops, or maybe even their smart phones as the client computers. So the clients will be accessing the server to get something done. Right? So that is called client server architecture. So the client server architecture also we can subdivide into two variations: central client server architecture and distributed client server architecture. So this is basically central client server architecture. In central client server architecture, you have a central server or maybe one or few centralized server. right? So server or one or two servers. So there are some advantages of centralized client-server architecture because that is very fairly simple to implement. But there's a big disadvantage when it comes to centralized client-server architecture, that is the scalability and reliability, right? So the scalability means basically when there are so many clients, right, hundreds of thousands of clients, when your business is growing, if a lot of clients are accessing your information system or the servers, the server is going to be in trouble because it can't now serve this much of high number of requests, right? So in that kind of situation, we have to go for distributed client-server architecture. The other disadvantage here is if when we have just one server, if by any chance the server is down, all these clients are not going to get their service. That means basically a total business disruption for the organization when the server is down. So we can tackle those issues if we move on to the variation called distributed client-server architecture, right? So when it comes to distributed client-server architecture, rather than just we are relying on one server, we will have set of servers, right? So here the servers are shown in close together, but usually what we do is we will have those servers in different geographic locations. If we have a network of branches, etc., we will be having so many servers in different locations, then each clients will be connected to their nearest server, right? Now you can see that the scalability issue is no longer there. Why? When more and more clients are joining our business organization, we can quietly increase number of servers as well, and some clients will be allocated to those servers. And you have to remember that those servers are communicating and collaborating with each other, syncing with each other. Therefore, regardless of the server you are connecting, you always going to get the same sort of a data. Okay, so that is how it fixes the scalability issue. And again, the distributed client-server architecture fixes the reliability issue also. Why? For example, when this server is down, we can configure the distributed client-server systems so that such that the clients will be redirected to the next available server. Then the client won't feel that there is an outage of the disruption of the service because it will be automatically redirected. So when we have more than one server, that is also possible. Now you can see the distributed client server architecture is more scalable as well as it is more reliable. So let's look at another general architecture uh, that is called peer-to-peer architecture. So remember in client-server architecture there are two distinct roles, the client role and server role. But when it comes to peer-to-peer architecture, what we have is each and every node is just a peer. So when we say that peer, the literal meaning is same level, right? Same level. So if you take organization, if you take same level managers, they are peers, right? So we are using the same terminology here, right? So peer-to-peer architecture, the peer node can both request and response, so both can act as a client as well as a server. So rather than calling them client or server, we just say they are peers, right? So there are some advantages of peer-to-peer architecture because it's highly scalable uh, approach, because we can easily incorporate more and more peers. But there are some disadvantages as well, because this is the biggest disadvantage is lack of control, because now we don't have sort of a same servers. Each and every node is sort of equal, right? But the scalability is really high when it comes to peer-to-peer architecture. So there are some specific usages of peer-to-peer architecture. If you have, I hope you have used torrents, right? So the entire concept of torrents is using peer-to-peer architecture. So that is why you can download some movies or whatever, as well as you can act as a seed, right? So you are a peer, right? So you are getting some information from another peer, and another peer will be getting information from your computer or your because you are also a peer, right? So there are some other usages also of peer architecture. One of the very famous usage of peer-to-peer architecture right now is cryptocurrencies like Bitcoin. So entire concept of cryptocurrency is based on peer-to-peer network, right? So if you have any free time, just read about those things, go to the YouTube, then you will understand how these concepts are working. Right, so what we discussed so far is uh, general architectures. Now we are moving to more specific enterprise level architectures, right? So that is actually our main idea here, enterprise level architectures. So we can subdivide enterprise level architectures into two categories, that is monolithic architecture and component based architecture, right? So monolithic means, basically mono means one. You know what is mean by the difference between carbon dioxide and carbon monoxide. So carbon monoxide is CO, one oxygen atom. Carbon dioxide is carbon connected with two oxygen atoms, right? So similarly, when we say monolithic, mono means one. You developed your information system as one big component, right? That's it. Just the system is just one uh, entity, right? So if we develop your system like that, we say we are using a monolithic architecture. But if you develop the system as set of components like this, now you can see these are set of components. These are set of components communicating and collaborating with each other. Then we say we are going for the component-based architecture. Right? So this concept of component-based architecture was basically borrowed from the computer hardware. So let's see the analogy from computer hardware also. Right, so this is to understand what is meant by component architecture. So this is a television. So the television is usually the hardware side is built using the monolithic architecture, but if you take computer, it is based on component based architecture. So this is not software component, this is hardware. This is just example we are taking. uh, Now here you can't identify well defined components, it's just one big circuit, right? So that is why it's very difficult to repair televisions when there are some issues, right? But when it comes to computer, you can see there are well defined components that we can plug into the motherboard, right? So the processor is a separate component, the hard disk and the other disks will be separate component, the memory will be a separate component, the monitor itself is separate components. That is why when something wrong with one component, we can just replace it, right? So we can easily upgrade our computer. So there is nothing called upgrading a television, right? But you can upgrade the computer, right? So we can have a different uh, monitor, we can have more memory when we need, right? In some cases we can even replace our processor with high speed processors, right? So all those things are possible when we are using component based architecture. So that is the component based architecture of the hardware. So the software developers also borrowed that concept of component based architecture. Now we can develop software also as set of components, right? Set of components. So when it comes to component based architecture, it is going to be more agile, easy to modify, easy to improve, easy to integrate with external systems. All those advantages are there when it comes to component based architecture. Okay, this component based architecture also we can subdivide into two categories, that is the service oriented architecture and microservice architecture, right? So the only difference between the service oriented architecture and microservices are both are component based architectures. In SOA, service oriented architecture, we have a lesser number of big components. So usually we call it coarse grain uh, components, right? So lesser number of uh, big components. When it comes to microservices, we have small components, but we need large number of these components, right? So both are component-based architecture. Both are having the advantage of component-based architecture, that is the maintainability, upgradability, etc., ease of integrity, etc. But some For some applications, we go for the coarse grain component based architecture. For some other applications, we might select fine grain component based architecture. It all depends on the specific requirements of the functionalities and the business organization, right? So typically, usually, the SOA is more popular than microservices because when we have lesser number of components with more autonomy, it is little bit more easier to or it is easier to manage it, right? So therefore, most of the time we go for coarse grain or the SOA than microservices, but there are specific advantages or usages of microservices as well, especially when it comes to Amazon Web Services. They are heavily promoting the use of microservices, right? If you're interested about microservices, the best thing is learn about how um, Amazon is having their own platform of microservices. Okay, right. So next we are going to discuss about another aspect, that is cloud computing. We briefly mentioned about this when we were discussing about on-demand computing as well as when we were discussing about edge computing, right? So cloud computing means you have your service or the infrastructure or the software services in a cloud. So basically cloud means somewhere in the internet, right? Somewhere remote location in the internet. So there are some cloud service providers also. In that case, those are called public clouds, where we can get some services by paying the rent or service charges, right? So that is now very popular right now, the cloud computing, because then we don't have to have our own servers and other things, and also we don't have to manage those things because cloud service provider will provide all those things with security and other uh, maintenance aspects as well. So we just have to use their services as a on-demand computing, right? So the cloud computing we can understand, or there are three ways of using cloud computing. This is very important for your exams also. That is infrastructure as a service, platform as a service, or software as a service, right? So IAA is infrastructure as a service, PAA is platform as a service, SAA is software as a service. Basically, infrastructure as a service means you are just renting an infrastructure, hardware infrastructure for your use. For example, you can rent a server, or you can just rent a virtual server, right? So then you have the full control of that particular server remotely, right? So you can have your web server set up there, you can install some software for your experimentation or any other purposes. Just at the end of the month you just have to pay the rent for that. Once you are done with that usages, you just stop the uh, usages and just you don't have to spend the rent, right? So you can see it's on demand computing. You don't have to have very big investment to have servers, etc. And also once you are done, you don't have to worry about that. The cloud service provider will be renting it to some other party which need that, uh, which have the same requirement. So that is called infrastructure as a service. I will come to the third one next, software as a service. Software as a service means they are not providing you the hardware resource in the cloud. They will provide you the software resource to consume, right, in the cloud. But the software is in the cloud, not in your computer, right? So now it is getting very popular. For example, if you take some of the office use of office packages, the Microsoft is heavily promoting their Office 360, right? So that is, rather than you install office packages in your computer, you have an account in the Office 360, then you can use the office packages like Word, Excel online using your browser, and also you can save your documents in the cloud itself also. And of course you have to pay for the uh, rent of using the service. So those are not much higher as you buy the, you get the license of the software, right? So the usually the when it comes to software as a service, the cost is going to be somewhat lower, right? Then in between we have platform as a service. So I just keep it for the last because it is the in between scenario. So there it is not just the hardware, or it is not an application software. It provides you, if it is platform as a service, the cloud service provider will provide you with the infrastructure, right? Or platform basically. Sorry, not infrastructure. It will provide you with some software platform. On top of that software platform, you can build your own applications, and not only you can build your applications, you can even host those applications. But those applications are not generated or built by the cloud provider. If the cloud service provider has built those applications, that is software as a service, right? But if they just provide you the platform for you to build applications, then we call it platform as a service, right? So platform as a service is very popular right now. For example, now we have the Google App Engine for Android phones, right? Any Android application developer can use the application platform to build applications, and also you can host your applications also in their cloud. The people who are interested about your application can just download that, use it, right? So that is application uh, platform as a service. So similarly, the Microsoft has Azure platform, the PaaS, right? So that is all about cloud computing. So cloud computing can be used in three ways: infrastructure as a service, platform as a service, and software as a service. Okay, so far we have discussed about the hardware infrastructure, the software infrastructure. Now we are moving to the third category, the IS infrastructure. Under that, data resources. Okay, so data resources means basically we will be discussing more about the databases, and also we will be discussing the uh, data warehouses as well, right? So when it comes to databases, we can subdivide it into two basically, what is known as the end user database and uh, external databases, right? So end user database means your database is in the your machine itself, right? So that is why we call it end user. So end user is your machine, so the database is also there. So mostly, or actually not mostly, typically end user database you will find in standalone applications, because in standalone application means everything is in the machine itself, right? So you don't have to connect to a different machine, or basically you don't need the network. So in that case, what you have is, together with your standalone application, typically what you have is end user database, right? So you can see this is a client PC. The database is, for the end user database is in the client PC itself, right? So that is called end user database. So end user database bases are not much used. It is a very small applications like standalone applications, like personal uh, say contact management system, personal accounting system. So personal, right? Then you can use end user databases like Access of LibreOffice base, etc. Then we have operational databases. So usually operational databases are the, the typical databases used in information systems, right? So the operational database will be most of the time in a server, and all those clients will be connected to, actually in this particular diagram you can't see here you have the operational database here. So the operational database will be connected to the network, or it will be in the separate server. So all the clients will be connected to that operational database, right? So if it is a enterprise level application, definitely end user databases are not going to use, it's not going to work. We need operational databases where each and every client is connected to the same database, right? So that is called operational database. If that database is in external location outside of your organization, right? So then we can call it external database. Basically external database is also operational database, just it happened to be in a some outside environment or some other locations. So most of the time those external databases are now cloud databases, right? So that means your database is hosted on a cloud environment. In that case, rather than saying it as operational database, we call it a external database. Okay, so those are the three type of three approach of having databases: end user database in your computer itself, operational database in a separate server in your business organization, external database it is hosted in a, or your external database or the operational database is hosted on a external locations like a cloud. Okay, right. So now we are going to discuss something related to databases, but something different from the database as well, that is what is known as data warehouse. Okay, so basically data warehouses are used to do some what is known as knowledge discovery or data mining, right? So usually a database will have the data that we are currently using, right? The data related to your transaction processing, etc. We are using these days, right? But when it comes to data warehouse, it has large number of historical data, right? So basically you will be at the end of every year or every month, you will be loading more and more data from the transactional systems to your data warehouse. So at the end, your data warehouse will have large number of historical data, maybe for last 10 years or last 20 years or whatever, right? So there's historical data, large files of historical data. So, so one thing you have to remember is this is, we are not taking data to the data warehouse for backup. No, definitely no, right? So backup is completely different thing. So here we are loading. Sometimes we are not loading all the data. We will be loading only data relevant to our data mining only. We will be loading to the data warehouse. We are loading those data to the data warehouse in order to do some data mining or what is known as knowledge discovery. Okay, so basically we do knowledge discovery or data mining in order to get business intelligence, right? So these are some more terms that we use in information technology, businesses related to information technology areas. Business intelligence means the organizations, or when we say organizations, the individuals and managers, they have better understanding or knowledge about what is happening or what are the trends, etc. when it comes to things related to business. So for example, if your marketing manager has a very good idea about the buying patterns of the customers, right? The finance manager has very good idea about the economic trends of the country, so that they have business intelligence. So business intelligence can be taken or acquired by reading a lot of articles and uh, referring to your internal artifacts like reports, etc. But if you need further business intelligence, you can use the data warehouse to do some analysis using the help of some software to identify some really important patterns of historical data. So that try to getting those historical data or understanding those patterns is called data mining. Okay, so when we do data mining, different managers or different people are interested about different aspects. For example, HR manager will be interested about the employee related patterns. Finance manager is interested about finance related patterns. The marketing manager is interested about the marketing patterns. So we have one data warehouse. Then what we have is the data warehouse softwares have the feature to generate some logical views. We call them data marts. Then individual managers like finance manager, HR manager can do their data mining on that logical portion known as data mart. For example, HR manager can do data mining on HR data mart. The finance manager can do data mining on finance data mart, right? So that is how it is happening. So basically data mart is, so these are some data marts. So data marts are not physically different things, they are just views, logical views of the data warehouse. They are just looking at what relevant to their field. Okay, right? So that operation is called data mining or knowledge discovery. The ultimate objective of knowledge discovery is have a better business intelligence, so they can do proper decision making, right? So these are two more terminologies we can use. The difference between online transaction processing or OLTP and online analytical processing. So online transaction processing means the processing of online processing related to day-to-day transactions like order processing, reservations, etc. Right? So those are called OLTP, online transaction processing. But if you are doing some analytical things, so again try to understand some patterns, etc., using information systems, we are not calling it online transaction processing or OLTP, rather we call it online analytical processing or OLAP. So just keep in mind that most of the time the management information systems will be involved in online analytical processing. So the decision support systems, they are involved in online analytical processing. The TPSs are involved in online transaction processing. Right. So now we are done with the hardware resources, the software resources, data resources. Right. Now we are moving to the human resources related to information in systems. Right. So without human resources, we are not going to use. So it's very difficult to get the usages from information systems. Right. So we can just categorize again. So we can have operations level human resources, IT professionals, information system development related professionals, the support related professionals, right? So the operation related professionals are basically data center managers, system operators or data entry operators, information system security analyst, right? Network administrators. They are operations related information system professionals. The development related professionals are software developers, quality assurance engineers, system designers, etc. Support staff include basically the database managers, and sometimes you can take system administrators also as part of the support staff. Okay, so usually we have this to coordinate these tasks. Our business organization may have a special position called uh, Chief Information Officer, and under that Chief Technological Officer. Right. So the Chief Information Officer will be looking at all the aspects related to information. The Chief Technological Officer is from the he is looking at the technical aspects of the uh, he may look at on maybe only looking at information systems technology, but sometimes the CTO will be looking at some other technological aspects like engineering aspects as well. Okay, right. So now we are moving to the final topic, subtopic, that is the globalization and its implications on IT management. Okay, so basically globalization means the world is now getting the closer and closer together. So sometimes we use the term global village. Now the entire world is like a village, right? So because of the advancement of especially the information technology and also some other things like transportation, etc., communication, now we are getting closer and closer. So the person, someone in UK and some his say friend or brother or sister in Sri Lanka, they now can easily communicate with each other, collaborate with each other. So they feel like they are very close together. Right? So same thing is applicable in business context also. The two branches, one branch is in Colombo, maybe head office in USA. Now we can easily collaborate with each other. We can have some online chatting, or we can have some conference calls. So we can just collaborate and work on same things. So with common objectives, we can just work as a team. So that facility is there, right? So that entire thing is called globalization, right? So when it comes to globalization, there are a lot of opportunities we can exploit, and also there are some challenges also when it comes to globalization. Okay, right. So when it comes to globalization, we have to think about two key aspects, that is global market and global staffing. So this is related to business. So now rather than you just looking at your own market or local market, and since the world is now getting closer and closer together with information technology, we can think of global market. That means we can always think of, can we sell it to international market, right? Not just here. So that opportunity is always there. Then we can do global staffing also. That means we can hire people not only from your country now, you can hire people from anywhere in the world and ask them to work maybe virtually or in their uh, local office in the or the regional office in different countries. So that is also there. It's a very big opportunity. If particular skill is not available in your country or the professions, you might hire them from some other country, right? And also you might hire some cheap labor also. If you have to pay a lot of money for particular professionals in country A, they might find the same capacity and same talent from some other country at lower rate because of their economic issues and other reasons. Okay, so global staffing can be done, and also global market is there. Both are great opportunities for business organizations. Right? Then there are some challenges also. Not only you have that opportunity, some big businesses in other countries also have now access to your local market. So that is the big challenge you have. So you have to not only compete with your local business competitors, now we have to compete with some global giants as well, because they have access to our local markets as well, right? So in order to be successful in globalization's context, we have to build our business also to the global level, right? So if we can build our business into next level, like expand it to some other countries for staffing, maybe we are doing some sales in other countries, then we are having a big all of a sudden our organization become an global level organizations, right? So when it comes to global level organizations, there are a lot of management related challenges, right? Business related challenges. So we are not going to discuss those things, but we are going to discuss is little bit about the IT related challenges. So information system related challenges if you are having a global level business organizations, right? So these are some aspects we have to consider: technical aspects, political aspects, economical aspects, cultural aspects. So we have to think about those things, right? Because different countries have different political sets, environment, different economical environment or the economic environment, right? Different cultural patterns. So we have to think, or even different technical aspects as well. The way the technology that we used in Sri Lanka may not be in some other country. They will be using some other technology rather than this particular technology. So therefore, you will find a lot of people familiar with the alternative technology, right? So when it comes to managing teams, we have to now, if you are a global organization, you have to manage your teams in global level as well, right? So you have to have, you will be having some teams in different countries. Sometimes they are working on same uh, development or same business tasks. Okay. So when it comes to global IT strategies, we can subdivide into three, that is international, regional, and global. So international means just one or two countries that you are interested in doing the business. So in that case, we say we need to have some international strategies, like we have in, so for example, we can say, okay, we have a local business as well as we try to expand it to say Japan, or just maybe Japan and South Korea. So that it's an international strategy. Then we can have regional strategies. If we are expanded to a lot of countries, we can identify, for example, Asian region or Europe region or maybe Middle East region, right? So it covers a lot of countries. So because these regions will have their own unique uh, requirements and demands, we can cater for these regions separately. So that strategy is called, that type of strategy is called regional strategy. Then of course, if you are a really big organization, you might have global strategies also. Those are the strategies that is applicable to throughout the globe. That means almost entire uh, world, any country that you are interested in doing the business. So the big organizations like, for example, Pizza Hut, McDonald's, Unilever, Coca-Cola, so they have all these three. So they have some global strategies, regional strategies. The same Coke will not be in the same taste when it comes to Asian country, and when it comes to European countries, because of the economic reasons and taste, their preferences, it may be somewhat different, right? So those are regional things. Then of course the international related strategies, targeting specific country, right? So those are important things. So when it comes to global business and IT applications, we have to think about the global customers, global products, global operations, global resources, and also global level collaboration. So I think those are very self-explanatory. I'm not going to explain much on that, right? So in order to build a global level business organizations, so you need some IT support as well. So basically now your IT infrastructure is also going to be a global level infrastructure, because you will be having some uh, business operations from more than one country. Okay, so in that case you have to think about how to manage networks, right, regulatory issues, technology issues, country oriented issues, etc., when it comes to managing global uh, IT platforms. Okay, so basically so that's it for the session. So let's move on to the objectives again and see whether you have achieved those objectives. Right. Now you must have a very good idea about levels of IS support: strategic level, decision making level, operational level, how to get competitive advantage by introducing information systems to increase profit, that is increase sales and decrease the cost, right? Then how to or what are the component of IT infrastructure: the technology infrastructure and human infrastructure. Then levels of IT infrastructure: remember the public infrastructure, corporate level infrastructure, the enterprise level infrastructure. Then the parallelly we have the corporate level or business unit infrastructure, etc. Then type of information system resources like hardware resources, software resources, data resources, and human resource aspects. And finally we discuss the globalization, their challenges and different ways of tackling those things, right? So I hope you got the big idea or the basic idea. So go through the notes again and think about those things. So don't memorize, okay? Don't memorize. Just think about those things in practical scenarios, uh, and try to contemplate on those things, and then everything is going to be understood. Okay, thank you.